Hey guys, today I want to share with you something I've been working on recently, which is how to use 2D nodes in order to make an interactive map so that you can interact with it. So um, here I just imported the a set of the map that I've been using on my other projects. It's just a screenshot from Google Map that I did change colors a little bit, right? It's way much more red. So here we'll be using this as a resource for this episode, but basically you can use any map you want to make. So it's quite a big day for this channel because I think if I'm correct, it's the very first time we create a node which isn't either gray or green. It is the first time we are using the 2D engine of Godot, and that's very, very exciting. So first, what we will do is simply begin by explaining how does the 2D engine works. So first we will create a 2D scene like this, and we will rename it world, okay? So the purpose of this node is only to provide a node container for the rest of what's going to be in the game. So we have a map, okay, and we want this map to be what we will be working with. So in order to bring this map to the world, it is necessary to create, oh wait a second, I will clear my .godot file folder. Okay, so I did clear the .godot folder and save the scene in a world folder, in my scenes folder. All right. So as I was saying, we need to create a node that will be dedicated to display the map. So we have tons of nodes, really. But what we will be using is simply sprite 2D. So yeah, it's definitely not just a sprite, it's a texture. But texture is for the UI, right? So here we want to use a sprite. So here, nothing super crazy. I'm just gonna bring the map in the sprite here and rename it map. Okay, so the first difference there is between UI and 2D nodes is that the UI is contained within this screen view right there. Meanwhile, 2D things are basically using the 0, 0 as the center of the world, and then it spreads on all four directions. So you can choose to not get this centered and have this kind of worked on as a regular interface thing, but I will keep it centered because it's actually quite easier for what I will be doing, right? So, okay, this is what we have right now. So we can start the game and you can see that basically the game is showing whatever from the world is overlapping in our screen view here. So obviously this is absolutely not handy. So what we can do is not center this. So it is showing like this right there. But there's definitely a better way to do that. To do the viewing is to actually add a camera. So cameras are very useful because basically what they will do is they will displace what should be showing on the screen, right? So that rectangle right there is actually now moving. So by default, the camera doesn't move at all. It takes a script to be able to move it. But for this very specific example, I will not be moving the camera, I would just use whatever portion of the map is showing in the camera, right? So just by adding this camera, we can now run the scene, and as you can see, that screen right there is actually showing what's under the camera. Okay. So here we have the map of a town in France. It's not named Angers, it's named Henri, but yeah, it's just my hometown, so I know this place very well. That's why I'm using this map at the moment. And we will actually be creating a few areas to be able to work with, right? So the point of this game will basically to have a few regions that will be pickable, right? So the first thing we need to do is to create those regions, make those regions visualizable, right? We need an easy way to know what is a region and what is not. And we will need to make those regions interactable. So let's begin by creating small areas. So in this map, I will create a node which is an area 2D. So areas basically will be the regions. Let's take a look at what they say about this node. It is a region of a 2D space that detects other collision objects entering or exiting. And we will use this collision object to actually get information with the mouse entering or exiting the collision of this thing. So here, when we create this area 2D here, which I'm going to name region, we have a little warning which says this node has no shape, so it can't collide or interact with any other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. So right there, what they say basically is that the region, the area, has no body, basically, right? So we need to create a body by using a collision node. So we have the choice between collision polygon or collision shape. I'm sorry if my breath is still on bronchitis, right? And I'm running out of hair very easily. So my voice breaking. So anyway, collision polygon 2D. Here, we will use this node because we're going to use irregular shapes. So this node is basically a node that provides a polygon shape to collision objects to the parent. So this is exactly what we want. Now again, we have another warning which says that the collision has no effect because the collision to the polygon is empty. So you can create polygons quite easily by using the packed vector2 array in there and then making points like this. All right, so let's create a first pigeon. So for example, actually in this region of the map in real world, this is basically where you have slate quarries. So I will make a big, well, I think it's this portion, I'm not very so sure. So let's just create a region in there by creating a polygon, right? So I will bring my polygon in my packvector2 array and start creating the points, okay? So I will just outline the region I want to be in. And there we go. So here I created my first region. Now, if I start the game right now, I just have the map, right? The region is just a collider. It has nothing happening to it. So if we want to be able to visualize this region, we can create other nodes which will be connected in order to have a visual display. So here we have a polygon 2D, but a collision of a polygon 2D. So what we can add is just a simple polygon 2D to give it a texture. So here I'm going to rename this polygon and I'm going to rename this collision. So here it is actually important to go give the points of the polygon somewhere. Uh, Data, polygon, array size, right there. So eventually, if we could bring this array to the other, it would be perfect, but it would actually come in the form of copy pasting everything, right? So I haven't found a way to do that yet in the editor. So I'm going in, I have my own way to do that. You might not like it and find different ways. I'm not aware of another way to do that. But what I will do basically is create a script in there, which is going to be my region script. I will give it the class name region, and I will get all the important variables, which are collision, here being a collision polygon 2D, and my polygon, which is my polygon 2D object. I'm going to grab those two objects in there, okay? And already, I will simply get my polygon, okay? And in there, let me show you in the inspector so that it makes sense. If I go in the polygon and that I go under data, I have this thing which is the property polygons, no, the property polygon, sorry, without an S. So it is the first list of vertices that will connect, that will basically create the shape, okay? And here we know that the name of the property is polygon. So it's exactly the same name as I gave to the node. It's okay. It's gonna be polygon.polygon. It's fine. There's probably more clearer names, but whatever. And what we want to do is basically assign to this one this shape that we have here. So here, exactly in the same logic, we have this packed vector 2 array, which represents the polygon, and the name is exactly the same. The property is also named polygon. So because of that, I can say that I want my polygon to be equal to collision polygon. Because of that, I should be able to start the game and have a shape, a white shape right there, displaying over the area that I created. Okay, so let's create another color which is a little bit better. Um, Maybe something in the line of oranges and have a kind of dark orange brown, but I don't want it to be plain, right? Because right there it's going to be plain, so it's not so sexy. I'm just gonna change the opacity to have it like this, 66 opacity. It's probably cool. All right, so here we have a kind of little overlay. It's fine. It's all right. It's exactly what I want. So now, just in order to polish this area a little bit, I will actually add a line that will make the edges of this region. So again, I'm going to create a new node, which is going to be line 2D. So what does Godot say about this? It's a 2D polyline that can optionally be textured. Okay, so basically what this does is that it has a packed vector 2 array that represents the points of the line. So if we actually give the points of the polygon right there, it will create a line between each points, right? So it will basically make the outer, well, the edges, the perimeter of the polygon we have. So let's get this line 2D in there. We get the line 2D, and we have line 2D, so we need to know the name of the property. Here it is points. Okay, so we're gonna grab points. So sorry, it's going in line. We're gonna grab points, and we will assign collision.polygon again. So it lacks something, but I want you to see it. Right there, we have the edges of the line, but it's not connected there because there's a little property that we need to check. So let's go in our line here. Here we have the property closed. The property closed allows us to basically say that we want the line to create a closed irregular shape. Exactly what we want to do. Now the white, it's way too big, so let's try 5. It's not that bad. Okay, it's not that bad. Now we have the capping. The capping, we should use this to have different edges for the joint mode. And I think round is not that bad because it makes the edges a little bit rounder. And I think we can try to tinker with kind of things to have anti-aliased, that kind of things. Basically, just, play with the options, check what every option is doing until you find something that is nice and decent for whatever you're trying to achieve. So I'm just gonna grab the color that I used for the area, and I will reuse that color for the line. Okay, I didn't copy it properly. Some of my shortcuts are definitely bugging. This is so weird. Okay, let's go with this one then. Okay, so we have this color now. And what I want to do is have it a little darker, something in that line. Oh, it's because the game is running, is that why? Anyway. Or maybe do I want it to be brighter, actually? Yes, maybe brighter. And less. Let's try this one. Okay. It's a little bit more visual. Okay, okay. So here, we now have the line around it. Perfect. So we have the area, and I want to make a visual feedback basically to say to the player that they are hovering over the area and that, yeah, that's something you can interact with. So we created a region here. The point of creating a region was that we wanted to detect collision entering or exiting. So here I will go in my node signals, basically, of the region node, right? It's important. It's not the shape one, it's the region node. We have the mouse entered, the mouse exited, and the input event. So here we will just grab the mouse entered and mouse exited. So I'm going to connect those two signals in my script. All right, so we have two new scripts right there. So what I want to achieve, basically, is that when I hover over the area, I want the color of the overlay to change to tell us, hey, you can interact with that. So that comes in a very simple form. I will change the color here, make it brighter, grab the color code, and revert it back to this base color here. And now, in there, when the mouse is entering the region, I want polygon.color to be equal to a new color being whatever I copied. So now, when I hover over it, the color changes. But obviously I want it to revert back to whatever it was before when I'm leaving. So here, I'm going to copy this, go in the script, and change the color when I'm leaving. So polygon dot color is equal to a new color being this one. Okay, so my copy thing definitely don't work. There we go. So now we can basically go over it and change the color. Maybe I want this to be a little brighter. Actually, no, it looks fine. Let's not overindulge. Okay. All right. So basically, we could be creating more regions by duplicating this uh, node and creating more and just changing. Well, let's do one. Okay. So that's going to be region 0, 1. And I will duplicate it to make region 0, 2. Here, region 0, 2, I will remove this right there. And I will find a place where we will be making wood. Let's have like, forest something. Um, let's go over there. It's gonna be fine. So here I'm gonna create a new region. Okay. And that will be this block here. Okay, I build it. Let me create a point. Sometimes it just doesn't work, sometimes it works. I'm not really overthinking it, I'm gonna create this big area. It's absolutely random, right? There's definitely not forests here, but it's fine. So here we have region 2. And now if I start the game again, we should see those two things. Or not. Okay, why? Here I have this region. Oh, maybe I have to display this guy, this guy. It's actually kind of not so cool. Okay. So now we can see we have two regions. All right. Let's fold this. Now we actually want this to be interactable and we want this to be used on other places in the game. So how exactly do we incorporate this thing in our user interface? Because if you've been following my material on YouTube, the main source and main thing that we have in the games are green and control nodes. So let's create a new control node that's going to be user interface. So here we have our user interface. Let's create a VBox container. And at the moment, the only thing I will do is create a panel at the top, which will be 80 pixels wide, or yes, it's gonna, I want to say wide. And that will be the header. And in there, I will have a label that will take the entire place, center, center, and I will make this label a header log. Okay. So basically what I want is to have the map in this space, and I want the label here to display what I'm hovering. Let's say this user interface, right? And let's create a script for it, like this, and I will have an export variable label, which is going to be actually header label, and I will reassign this. So here, I will change the script a little bit in the map here. I will add a new variable, which is going to be export, and it will be the region name, and that will be a string. So eventually, if you've watched my Pocket Clicker series, you could use the database system, and instead of using a region name, you could use a region key or database key, right? But here we're going to use a string, which is going to be the name. So now I can go in the editor right there and change this to quarry or slate quarry, and here to be forest. Let's have it like this. Okay. So now I will create, so let's remind you what I'm doing here. I basically want the label to display what region I'm hovering here. Okay, so I need this region name to get out of there. And I will get it out with a signal by using mouse hovering or mouse entering, and I will use an argument which is the region name, and that argument will be a string. I will also use a mouse exiting. Is it exactly? Oh, okay. Let me think, because the way we name signals is past tense, but I don't want this to be the same that already exists, so it's gonna be something different. Okay, it doesn't make sense, but it's gonna be mouse hovered and mouse unhovered. Okay, don't think this too much. I just want this tutorial rolling. You will find better names on your own. So we will basically emit the signals with the string value going with it. So here we have mouse hovered dot emit with the region name, and the same mouse unhovered with the region name. So now I have this signal existing there. So what I will do is I will create a world script. The world script will have the exact same two signals with a region name and a signal mouse unhovered with a region name. The reason why I want to do those signals here is because it will take all the connections from there, and it will basically gather them in one big signal that can be used by other nodes. So here, let's create a new function, which is going to be on region mouse hovered, which will take a region name, and I will make exactly the same, but with unhovered. So on region mouse unhovered doesn't exist, but I don't care. String, void, and pass. So here we just want the new signal, mouse hovered, to be emitted with the region name, and here we want mouse unhovered to be emitted with the region name. So now what I will do is I will create a ready method. And what I will take is all the regions in there. Okay. Um, in order to get all the regions, I will create an export variable, which is going to be the map, and that's a sprite 2D node because there's nothing more at the moment in this node. So let's have the map here. So we have access to this node there. And I will create a variable regions, right? Which is going to be an array of node. It will be equal to map.getChildren, like this. So here we're creating a list of all the regions in there, which are under map. Now that we have the region list, we're going to go with for region, this being a region. In the list regions, for each unit, we will be doing region.mouseHovered, and here we will connect on region mouse hovered. And I will do exactly the same for the other one, mouse unhovered, and I will connect to this signal here. So now when I start the game, it should be exactly the same as before, except that we have signals being fired away. We don't see those signals yet. So let's go back to the user interface because now we do know when we are hovering over a region and when we are exiting a region. So in the user interface here, we want to show the map. So there are different ways to do that, and I will show you the sub-viewport way of doing that. So in my VBox container, I will add a sub-viewport container. So it is a container used for displaying the contents of a sub-viewport. So as you can see, it's a green node. So it is designed to fit in the user interface. Right off the bat, I will go in the layout, give it a container sizing, expand because I want it to take all the space available. Now we have a warning. The warning saying this node doesn't have a subviewport as child, so it can display its intended content. Consider adding a subviewport. So here we will do exactly that by adding a subviewport node. So what Godot says about it is an interface to a game world that doesn't create a window or draw to the screen directly. So basically, the game in and of itself is a viewport. But what we're saying is that we're going to create a new view within the game that has its own viewport, which is why it's a sub-viewport. It is a viewport within the viewport. A simple way to visualize this is think about mini-maps. Let's say you have your main game with your camera moving around the map, the world map, and then you actually want to have another camera, which is here, that's a map, so we're going to say this is the minimap. You have the camera moving around the minimap, and you want both to display on the screen. But the game doesn't handle multiple cameras. So what you're doing is you create a specific spot that will say this will display its own camera. Okay? So here, we will just have this subviewport there and drag the world in there, like this. So it's a little bit clunky because again, I want you to keep in mind that what will be shown is the camera. So of course it's a little bit on the side. Maybe we can, no, we can't see it exactly, but if we want to see exactly what's happening in there, we need to go in the world node. So anyway, we should be able to, oh well, sorry, I forgot a few things. Yes, we need to stretch the subviewport container. Because right there, if you look at the subviewport, it has a size which is, I want to say, manually edited. So we want to use the stretch property, which says that the subviewports will be automatically resized to the controls size. So we are sizing the container, and then the subviewport is taking the size of the container. So now we should be able to start the user interface, and we have this map displaying in there. Maybe, let me see. Maybe I will get rid of the camera in the world because it doesn't make sense being here. And instead, I will add a camera in there. So we have the world and we have a camera. All right. We have a little bit of spacing there, which comes from the box container. So we can get rid of it like this by overriding the separation with the 0. And we have the map. So we have those things on the sides because the resolution of the map that I'm using is too little compared to the side of the screen. But yeah, you could use a bigger map if you wish. So right there, the first thing that comes up is that we can't hover over the regions anymore. So in order to change this, we need to go in the subviewport settings and go in the physics to allow the object picking. And well, I think at the moment we just need this one. Yes, we just need this one. So now the regions do react to this again. All right. So here we have the world, which triggers two different signals, mouse hovered and mouse unhovered. So what I will do is just connect the signals to my user interface script like this, user interface script, and I will do something very simple. When we get in a region, I will change the text of the header label to be equal to, let's say, let's just give it the name. Let's just say region name. Well, actually, we can use region name. And when we leave, we want the header label.text to be empty. Okay. So now I can start this, and when I am above a region, I actually have the name of the region displaying. All right. Do you want to do something more? Yes. We have something in the debugger. What is it? The parameter region name is never used. Yes. This can be useful in a behavior that I'm not going to describe right now, but basically when you have regions which are very close together, the entering and exiting can be a little bit clunky, so it's actually important to keep track of situations where you actually you change the region and you basically change the focus. So it's kind of tricky to explain, but it can be buggy, what I just did, if you have regions which are very close from one another. All right. So let's create something very simple. Let me see. So here we have the user interface. Let's go in the world. Right there. Thing here. And I want to use the input method. Or what is it required for the input event? What are the inputs? So we have this, all right. And I will go with if event is input event mouse button. Let's create a button event. Let's make this check. If mouse button is here, we have a variable which is button event, which is an input event mouse button equal to event. Yep. So here I'm going to go with if button events dot button index equal 1 and button event dot pressed. Yep, I want to print yay. Okay, so let's try this. So it's triggering twice. That's unsettling. Oh, I actually want to check that it is in front. It's actually hovering. So let's use the other method instead. Let's try this one. Yes, it was the other function, right? So this function is working for the area 2D and the other one is just for the global input. So it's my big bad. So let's summarize what happened here. We have this method that triggers when an event happens with the area 2D. And what we want to do basically is now to emit a signal that will say that it has been clicked. So let's create a new signal being region clicked. And again, it will take a region name like this. And here we will emit the signal by saying region clicked. We want to emit region name. Okay, so here I will create the same signal again, region clicked with region name like this. And I will go with on region clicked, region name, string, void. I'm creating the method that will send this signal away from there. I want to share the region name. And of course, I need to connect it. So region clicked dot connect on region clicked. So there we go. We connected the signal to the world script so that it is triggered and emitted from this script as well. And now we need to grab it in our user interface. So here, my world, I will grab this and connect it to the user interface, and I will create an enum, which is going to be the state, like this, and I will create idle and processing. All right. So here, very simple. I will change. Oh, well, I need to create a variable. Sorry. So here I have the variable state of state. Let's give it a capital letter. So yeah, state by default is going to be equal to state.idle. So here, when we click, we want state to be equal to state dot processing, and we now want to change the header label let's see if, well, let me see. Okay, if region name, let's go with var text, that's going to be a string, and I'm going to go with a match of region name. What is it? Is it case? How does match work? Is it, oh no, I think I just have to say like this. Yes. And text is going to be equal to mining. And then I should add forest and text equal to lumbering. I think match worked this way. Okay. So what did we do? Yes, we did state, and we want basically the state to change to processing. Then we want the text to be either mining or lumbering based on the value of the region name we are exploring or clicking on. Of course, we want the header label to update, so header label text on this to take on text. And there I will just be sure that we have this if state is equal to state dot idle, then I want to change the label. And here I'm going to do exactly the same. If state is equal to state dot idle, then I want to change the label like this. So now if I run the interface, I should have the slate query and I should be able to click to say mining. Okay, I should be able to click on the forest to say lumbering, and we are almost done. I will just add a timer there, timer node, which is going to be 5 seconds. And on timeout, I will have this unused timeout method here, and that will be state is equal to state dot idle, and header label dot text is going to be equal to this empty string. So let's get the timer in our export things. So here we are going to grab the timer there. We're going to grab the timer in the interface. It's a one shot, it's not an auto start for the timer. And right there, when we are done setting everything ready, we just get timer.start. Okay. So now everything should be okay. I should be able to have the slate quarry, add a forest, begin lumbering, and let's go. Just one thing. Here I want to make a check, which is state. If the state is processing, I'm going to return and do nothing. Okay? So now, yep, let's just make this a little bit faster. 2.5 seconds. And there we go. So we can click on somewhere, it's mining, it's lumbering, and we can do anything different. Okay, well, Actually, the light has changed quite drastically since the beginning. It's alright, you don't need to see me that much. So anyway, that's all I'll be doing for this first video on the interactive map. There is obviously a lot more we can do to improve this thing and make this game more interesting. But at the moment, that's all we will do, and eventually this will come in the form of a new series where I will be making a game, a simple game, that will use 2D nodes more and interactable maps, interactive maps, etc. etc. I hope you liked this episode very much. I've been tinkering on this quite a while lately. It's a lot of time trying to figure out how to put this video. I still believe it's not brought to you in the best way, but since it's not a series but just a random video, I think it's fine. It's more me sharing with you some of the results of my experiments. So yeah, I hope you like this, and I will see you in a next video as soon as I have something more to show you. Take care and see you later.